Okay, we're going to go back and we're going to solve some equations, but we're going to do some special ones called absolute value equations. This will set us up for the rest of section 1.6, where we're going to solve absolute value inequalities. They're going to link to not only absolute value equations, but they're going to also link to our compound inequalities, which we had just done. So let's talk about absolute value first. Of course, we've got our symbol for absolute value, which looks like two very vertical bars surrounding a number. Now, absolute value is special because it is just the distance from 0, between a number and 0. So if I take the absolute value of 6, it means I'm asking you how far away is 6 from 0? Well, it is 6 places. And if I ask the absolute value of -5, I'm really asking you how far away from 0 is -5. Well, you're going to tell me it is 5 places away from 0. So both of these give me a positive answer because you're just telling me distance away from 0. So it is always positive or 0 if you're asking me how far away 0 is from 0. So if I were to graph absolute value, let's say I say the absolute value of x is 6, that means I have two possibilities for this answer. X could either be -6 or 6. So this is what the graph would look like, these two positions. So my outcome would look like this, the solution of 6 or -6. Okay, so here's an absolute value equation. The absolute value of b minus 3 is equal to 5. Okay, so whatever this is, its absolute value is 5. So I know from before that I have two possibilities, that I have an absolute value that is either somewhere on the negative side of 0. Whoops, let's do this. Somewhere that is either over here where it's negative or somewhere over here that is positive. So I need to solve two equations. One that will give me a quote-unquote negative absolute value or a quote-unquote positive absolute value. So I have kind of two cases, two equations to do. So I'm going to do a negative and a positive. Well, here's how I do it. I need to use this expression, this b minus 3. So you can see it. I have b minus 3 here. I also have b minus 3 here. And I'm going to use this 5 in both places. So here's 5 and here's 5. Well, when it's positive, I change nothing about this equation, except I'm dropping the absolute value bars. When I do my negative, I'm going to do the opposite of this expression. Okay? Just as if I were going to do maybe the opposite of a 6 in here, or the opposite of a 3 in here, because a -3 would still be 3 places away, just for example. Okay, so I'm going to do, basically, if I have a negative in front of here, that means I really have what's understood to be a -1 in front of this set of parentheses, which means I have some distributive property happening. So I would distribute a -1 inside the set of parentheses. So I'm doing -1 times b, and -1 times -3. So I would get something new down here on my steps. So I would have a -1b, and then this -3 times -1 is a +3. And then I go about solving my equation. So I would need to cancel out this +3 by subtracting, and then I have a -1b left over. Let's see, let's cancel this out. And then 5 minus 3 is 2. So I have -1b is equal to 2. I need to get rid of this -1. So this is -1 times b. So I need to divide. So 2 divided by -1. I have a -2. And over here is super simple. I need b by itself. I got to get rid of this -3. I got to add. I get an 8. So my answer is the solution set right here. This is giving me a solution set of -2 and 8. So here's the -2 I got. Here's the 8 I got. All right. So I need a negative case and I need a positive case. So the opposite of this equals to my 5, and just this straightforward equals to this 5. So let's see another one. Sometimes I might have an equation that has a whole bunch of stuff going on. I have a -5 subtracted out here. I also have a 3 that's sitting in front. Anytime you have something written right next to a variable or right next to a set of parentheses, which is what our absolute value bars are going to be behaving as right at the moment, I need to get rid of all this stuff first before I can write those two cases. So first I need to cancel out this 5 and move it to the other side by adding. So I'll cancel this out, add it over here, which is going to give me a 9. And then I'm going to need to cancel out this 3. Well, if this is multiplying by all of this, I will not distribute this in because I have absolute value bars here. And even though they're acting as parentheses, what I need to do is divide them out. I will not distribute them into the absolute value because I'm taking the absolute value. I need to take the absolute value of a negative something and a positive something. Well, this has no absolute value applied to it. It's just a regular 3. So I want to divide it out. I'm going to cancel it out first. So I'm going to divide it out. I will divide it out on both sides. So it cancels here, divides into the 9, which will give you 3. So here's my equation that I will do the negative and positive case of. So 2x minus 3 equals to 3. So this is the 3 that I will keep, and this is 2x minus 3 that I will use as my expression. So what's my negative case? Well, it's going to be the opposite of 2x minus 3 equals 3. So I will need to do that understood 1, which is really a negative understood 1. I'm going to distribute that in to all of this, which will make this a negative 1 times 2x, which is a negative 2x. Negative 1 times minus 3, so you'll have a positive 3 here. And then we'll need to solve this equation. Of course, this is straightforward over here. We'll get to that in a second. And then I'll cancel out that 3 by subtracting. And then I'll have negative 2x equal to 0. If I have to divide this out, what is anything? What is 0 divided by anything? If I divide this 0 by this negative 2, I'm going to get a 0. So over here, my expression did not change because this is the positive case. So I just brought this expression over, and I brought the 3 over. Of course, this 3 didn't change over here either. The only thing I had to do was the negative case of the expression. Positive, everything stayed the same. Just drop the brackets, the absolute value bars. Add the 3 to cancel out. I have 2x equals 6. I need to divide by that 2, and that gives me a 3. So I have the solution set of 0, 3. Let's see what we got going on here. Okay, so this is another case where I had something hanging out here. Let's see what happens here. I need to get rid of this 14. I'm going to cancel out over here. I end up with the absolute value of y minus 4 equal to negative 3. Now, if absolute value is really just distance, can I have a negative 3 distance spaces away from 0? Or negative 3 spaces away from 0? Or a negative 3 distance? No, distance is not negative. We're not talking physics. We're not talking vectors. We're just talking just straight up distance. So distance is negative, never negative. Absolute value is never negative. So this will be a no solution, okay? Because of the definition of absolute value. So this is not possible. And I just wanted you to see this is the no solution symbol. So remember, no negative 3s. If you have anything lurking on the outside of the absolute value bars, take care of it. Do your regular equation canceling out and get rid of those first before you go about writing your 2 cases and solving for your equations. You will always have 2 when you're solving absolute value equations unless you get this negative, which is a no solution.